afternoon, everyone. Thank you for attending. Let me just start sharing my screen. My name is Dean Mikkelsen, and as we said, I instruct at the American University in Kuwait as well, and I've been teaching cyber for the last almost 2 years now through the American University of Kuwait remotely. So on financial, on securing our systems, education, training, to make sure that our systems are secure. But I'm going to turn our interest to positioning, navigation, and timing. And let's take a look specifically into the Middle East, the area of interest of mine, where I've worked and lived from the UAE. Currently, right now, I'm based in Tunis, Tunisia. So there's a lot that's happening in this region. And what we've seen in this region is a lot of spoofing and jamming, which we'll explain in our next few slides. And this has happened mainly due to geopolitics along the Strait of Hormuz and the Red Sea, Gulf of Aden, the Arabian Sea. We've seen this happening. We've also encountered it in the Eastern Mid towards Lebanon and Israel as well. We've seen situations where there's been cybersecurity events. And as some of our previous speakers have presented, the incident in Natuns as well, the cybersecurity event there on land, so not maritime specific. We had Saudi Aramco with another event that happened there with NotPetya happening, bringing down their systems. So cybersecurity plays a big part of the Middle East and within the maritime aspects of the Middle East. So let's just take a look at first some facts about shipping in the Middle East. The Bab el-Mandeb, Reuters shows that Saudi crude exports for the Bab el-Mandeb, which is about 18 miles wide, and its narrowest point is Djibouti, estimates there's 500,000 to 700,000 barrels per day that transit through that small waterway. And then we've got the Strait of Hormuz, where we've got multiple task force in there, from Imash to a mix of different countries operating, cooperating. The Koreans are also there as well. And the Koreans recently had an event that affected their ships. And one of their ships actually was, the Iranians said it was an environmental disaster, environmental issue. So they brought the ship over. And it took about 2 months of negotiations and trying to free up some funds that were being held to get the vessel out. It wasn't a cyber event, but you can see geopolitics play a large part in this part of this world, and cyber is one aspect of it. So we've got the Strait of Hormuz, we've got Saudi Arabia, which can export off of both the Red Sea and through the Arabian Sea as well. Then Iran, Iraq, Kuwait, United Arab Emirates, and Bahrain. And almost they rely entirely on the Strait of Hormuz currently. There is one Fujairah on the southern side of the UAE does allow for exports outside. So there is some workarounds, there's pipelines being built, but we have these constriction points. And this is where, amazingly, cybersecurity can come into play with our vessels and our ships. So if we go on to the next slide, we want to take a look at the global navigation satellite systems. In my background, I've been involved in GNS for quite some time. When they first initially came out in the early 90s, 94, 90s, 80, through basically 89 to 94 was when the initial satellites started coming out, was GPS. That was the first one. And everyone knows GPS. You see it in your phone when you're, everyone knows what that is, but there's multiple different systems out there. But at the time, we had not as many satellites as we do now. We have 36 satellites within the GPS constellation system. When it first came out, there was only about 8 to 10, and then there's different versions, and we're getting better at positioning the navigation. But the single is quite weak. We can overpower it. So other countries and nations start developing their own satellite systems. Russia developed the Global National GLONASS, the European Union's Galileo, China's Beidou, and then we're looking at different types of systems that can be used as well locally. India is developing their own system just to handle Indian navigation within their waterways and areas. But in the past, we've had LORAN-C, we've had different types of navigation systems that can help. Now we're moving towards ELORAN. We're looking at low Earth orbiting objects or satellites, LEO satellites, that can help based on timing as well. Because what we're going to experience in this presentation and show is spoofing and jamming. And how do we protect ourselves from it? And what is the legal obligation for us to do it? Through IMO, and there's some recently released suggestions or recommendations. And that's the one part that we've got to look at. With the IMO considers cybersecurity, it puts out recommendations for it, but it doesn't say it's mandatory. And we'll cover that as well. So that's one weak part that I see within our IMO legislation. So if we go on to our next slide, the IMO requirement. So in 2017, the IMO issued MSC circulation number 3, Guidelines on Maritime Cyber Risk Management. They provided a high-level recommendation to safeguard shipping from the current and emergency cyber threats, vulnerabilities, including functional elements that support effective cyber risk. Now, there's 2 parts to this. There's the part A and part B. Part A is mandatory. And guess where cyber falls in? Cyber falls into the recommendations, part B. So it's not mandatory. And like many organizations, we see cyber, they see cyber as, it's just part of IT, it's not important. It doesn't hit the organization till an event happens. As our previous speaker mentioned, the Marsk incident, which is, it kind of brought cyber to the forefront of Mars. They said, holy cow, what have we done? We weren't prepared for this. We didn't even anticipate this. And they rebuilt their whole cyber organization. And now it's become a part of the business. Yes, the IMO has made the recommendations mandatory, but it's based on the state level. So the US, yes, has recommended, and we'll cover those as well. Coming up next. So if we can move on to our next slide. So what we've incorporated was the maritime cyber risk management and safety management systems. And often, sometimes safety management systems, it's a big term, but sometimes it can be as simple as an Excel spreadsheet for many organizations. How do we maintain keeping our systems safe and stuff? So what we've also encouraged as administrations to ensure that cyber risks are appropriately addressed in existing safety as defined in the ISM code. And it was mandatory up to the 1st of January 21 to have this implemented, to have it implemented within the shipping organizations. So they had this deadline to try to get this one aspect implemented. So a lot of organizations were playing catch up to do this. It was kind of like, we probably meet this deadline, we will meet this deadline. So they slowly met this deadline, and it's slowly becoming more and more into play. So when we go on to our next slide, please. Let's cover jamming and spoofing. Spoofing is essentially, from a cybersecurity perspective, a man-in-the-middle attack. We're basically feeding false information by transmitting the signals to the target ship. But what we've done is that signal is stronger, so it overtakes the GPS signal that the ship is receiving. So the ship begins to trust that signal. And there was an example that the University of Texas did. They basically directed the signal towards a receiver on a vessel off the shore of Spain. And what they did is they directed that signal, said, this is the position you are, this is where you're going. And it eventually overtook. And the ship basically turned 2 to 3 degrees off course of where it thought it was going and where it should be going. So they basically showed how easily this could happen with this one test. They have a video on YouTube as well. And then let's move on to jamming. One sec here. Slowly we're getting there. And was jamming, it's the deliberate transmission of single frequencies used in an effort to prevent the receivers from locking onto the authentic GSS signal. So we're jamming it. We're saying, no, no, you can't get the signal. You can't feel the signal. We can't receive it. It's a deliberate blocking of that signal. So what can we do? So right now, GPS is the most commonly used satellite system out there. And there's multiple other systems out there that we've mentioned. But it costs money, it costs different ways to move into these different systems to accept them. So we've got to look at multiple types of GNSS devices to prevent these types of events from happening. Because let's take a look at an event that happened in Iran coming up next. The Stena Imperial was a potential spoofing which happened in 2019. It was passing through the international waters in the Strait of Hormuz. And then on 19th of July, 2019, it was detained by Iran's Islamic Guards near some disputed islands that are in dispute between Iran and the UAE. And basically they said, again, they point to another environmental disaster, but it's suspected to be spoofing because there's no reason for the ship to go off course. It started doing it on its own. So that's why we say it's a potential spoofing attack that happened. So it was following a different course of where it should be going. And remember, we can spoof markers offshore, we can spoof. There's a lot of different areas that we can spoof within the shipping industry, especially in international waters and conflict zones. So Stena Imperial was one of the major first attacks that's been documented by a nation state. And as you can see, a lot of nation states come into play in cybersecurity, whether it's through APTs, through other areas, through cyber criminal groups, everything. Nation states can play a lot within geopolitics, and shipping falls into this, amazingly. Sometimes we forget about shipping, but it's an important part of our supply chain, especially when you look at the oil and gas and all the goods that get transported, even through like the Suez Canal, when we witnessed the Evergreen incident as well. Saw the importance of shipping. And actually, someone even posted on Twitter, was this a cyber attack? No, it wasn't a cyber attack, because the way the shipping industry works through the Suez Canal. But there was potential that you could have a cyber attack that could do it and fouls up shipping through the Suez Canal, even though the likelihood of that is quite low at this point. Our next slide, please. So when it came to GNS interference, jamming, and spoofing, the Maritime Administration in the United States issues basically advisories, and this was one of the advisories that they released, to be aware that the interference is a result of loss or inaccurate GPS signals that will affect your bridge navigation, your GPS timing, your communication equipment, your satellite communication equipment. Remember, everything is based off of satellites nowadays. In the old days of shipping, we would do like a lot of dead reckoning. We know what to do, where we're going. But right now, we are so reliant nowadays on satellites, on GPS. People are driving their cars reliant on GPS and for directions, navigation. And sometimes the GPS is wrong. They'll drive into the water, or they'll say, well, my GPS told me to go this way. So they'll drive off into the water somehow, down a road, and they'll just keep on driving and take them straight into the ocean. These events have happened worldwide, and we have become so reliant on technology. But sometimes the technology has a good and bad purpose, and it can be used or manipulated incorrectly. And so MARAD, the Maritime Administration of the United States, is saying, be aware that situations do happen. And they keep posting these continually when events like this happen. So let's take a look at our next slide, please. through our cyber policy and guidance. So IMO recommends that there are multiple sources of information for navigation and position data on vessels. This is not a mandated requirement, it's recommended, but they also recommend that all critical systems have in place a cyber defense system capable of anomaly detection, which will alert operators to odd jumps or drifts in position based on previous and current position, planned route, and ship speed. And this will prove an indication that the GPS may be compromised. So the idea is that we want to determine, are we being compromised? Are our systems detecting this? Because we've become so reliant on the technology. And there are various ways that we can detect this compromise. But often as not, it's training, learning what's going on, being able to recognize it. Because the navigation can affect, even as we go into ports, if ports are busy and are following our navigation tools and the technology there, we could hit another vessel. We hit other vessels coming into ports just on a regular basis sometimes. You can see videos on YouTube. One just recently happened as well, where a vessel was coming in and it was navigating and they hit a crane and the crane collapsed and it also hit another ship. These things happen. Again, it may be human error, it may be not following navigation, maybe speed, but these are all critical systems of which the human plays a part of it. So how do we make sure that our navigation systems work and that are not being compromised? And the slides take a little bit of time to come up. And then we take a look at the BIMCO, the Baltic and International Maritime Council, has defined basically a cyber safety incident as any incident that leads to loss of availability or integrity of safety critical data. And this includes your navigation and positioning data. So BIMCO recommends using commonly accepted cybersecurity best practices, which are similar to the NIST standards, which our previous speaker covered as well. So these include having a plan that will identify the threat environment, how are we being spoofed or jammed, what are our vulnerable systems on board, where can hackers get in, where can we be penetrated. Let's assess the risk exposure by determining the likelihood and impact of a vulnerability exploitation. How can we develop protection and detection measures, which we'll cover? How can we establish our contingency plans? What happens if we are breached? What happens if our navigation system is breached? What happens if we look like we've been compromised? How do we respond and recover from this event? So BIMCO, via the NIST standards, lays out some guidance material as well. So we've got several organizations recommending this. And then Executive Order 13905, Strengthen National Resilience through responsible use of positioning, navigation, and timing surface. It got started in 2020 last year and finally came into law within the US in February of this year. So it recommends making available GNS dependent source of coordinate universal time, that they want to have a national R&D plan for PNT. The US has recognized that PNT is important and that we want to develop a PNT profile, a cybersecurity framework for the responsible use of PNT. So, and have it sector specific, because it affects multiple different services, whether it's transportation services of trains, trucking industry, shipping. We use PNT services constantly throughout our life. So we want to make sure that they are secure and safe, and shipping falls into this. How do we make resilient systems to handle this? So the US is looking at mandating more environments, more tools, and making systems much more secure if they can, through data encryption, possibly, but again, that's modifying the technology, getting more satellites up there that are more secure. So that way we can protect our PNT surfaces. If You gotta remember, clocks nowadays are set off of timing systems. The satellites are based off of times. So when we determine our distance, when we determine, everything is determined off of time. The time helps determine our location. That's why it's important. So we want to make sure that these systems work. They all come into play within our navigation. And this was the foundation put into play. So there are, I'm going to go through some 5 key considerations that they consider. So what we want to look at on our 5 key consideration points are, give me one sec here. What we're looking at here is we want to consider looking at what devices use our PNT services on our vessels. That's our first step. Let's assess our technology. We always do an assessment. What's our current state? Where are we? What's our baseline, as our other speakers have said? So we may not realize what is actually using our positioning, navigation, or timing systems. Timing we may not consider. Our clocks on our vessels. Everything relates back to the timing, relates back to positioning, helps our navigation. So we want to consider incorporating our step number 2, alternate PNT sources into our business. So that may be ELORAN, LORAN-C, low Earth orbiting satellites. How can we come up with different systems that can help protect our navigation? How do we come up with procedures to detect data manipulation, disruption, or cybersecurity events? Number 3, do we compare to multiple sources? Have we got multiple receivers on our vessels? How can we enable the detection of the manipulation of PNT services? Is there ways that we can actually spoof the person who's trying to spoof us? So we also want to consider the policies, the procedures and plans to respond to that disruption of PNT services. We want to make sure that our staff understands this, is able to recognize it. So let's consider the next step after that. How do we recover or restore systems affected by PNT service? Is there various ways that we can move on from this? Okay, we've found one error occurring within our receivers. So do we close that off? What do we do? Again, this redundancy, this possibility is one way. So let's move on to our next step. So we want to improve the resilience of our GNS signals. So what we can do, there are multiple ways that we can do this. We can obscure antennas. We can install antennas where they are not visible from publicly accessible locations, or obscure their exact locations by introducing impediments to hide the antennas. So what we're saying here is, with that example of Spain, offshore Spain, we directed the signal towards the antenna. But if the person who's trying to jam or spoof that antenna can't see it, then we've protected that aspect. We've protected one of our points of attack. So again, what we're trying to do is protect ourselves from being penetrated. And the next step that we can do is provide decoy antennas. We can leave or install a clearly visible antenna as a decoy and connect it to a sensor. This sensor is kind of similar in cybersecurity of what we're trying to do is a honeypot. We're saying, okay, I'm available here. Let's detect it. And then we can figure out if we're being attacked. And that's what we're sensing. So we're placing it in an application that's readily observable from accessible places. And it's far from the actual antenna. It could be 300 meters on one of our shipping vessels. It could be at the front, it could be at the bow, it could be anywhere on there. So what we want to do is we want to provide decoys and have our attacker go after that decoy. We've created a honeypot, so to speak. And once we start measuring, seeing what's going on, okay, we are being attacked. We are getting stronger signals coming through to our decoy antenna. We can know how to prevent that from affecting our other antennas within our vessel. So there's various ways that we can do it. This is just two. And what we also want to do is carefully select the antenna locations. So we want to make sure that the antenna is visible, but it's above infrastructures, and we can get multiple signals coming in, and it has an adequate view of the sky. Because you got to remember, if we're spoofing our ship or our vessel, a lot of times it occurs from another vessel, it could occur offshore, so the angle makes a difference as well. So we want to take a look at a greater angle coming from the sky and not coming from the shore. So we could say something like 25 degrees and above, we will accept singles from. Anything below 25 degrees, we will not accept that single. So we're slowly building different ways that we can prevent the spoofing from occurring. Then we also want to incur blocking antennas. And these antennas will help protect the receiver from interference and jamming. And they can also attenuate. We'll see spoofing signal happening. So these can be surrounding our antennas. And the way that I've been looking at quite often now is redundancy. If we can install 2 or 3 antennas, it drives independence. Plus, we also know what the difference is between the spacing of these antennas. So if the spacing increases, then we're experiencing something happening. If the distance between them increases or decreases, something's happening to one of our antennas. We are experiencing a discrepancy. So we know something is happening to our location information. So we can start looking at other sources of receiving or positioning information, or we can start closing off the antennas that we don't want to use where we're experiencing this attack occurring. So what we've introduced is a lot more hardware, which unfortunately does cost a little bit more money, but it will help protect your current systems based on the current technology that we have. And then calibration comes into play. How is calibrated? What are the delay characteristics? Is it making sure that it makes sense? Is the delay small? Timing. The reason why delays come into place is because are we getting delays in our timing signal? Is it being overpowered? Is it coming more frequently, this timing signal? So we want to make sure that it's calibrated and we understand how our receiver or antenna is working. So calibration comes into play. One of the key areas, though, is the redundancy is one of the easiest ways of making sure that your ship is not being spoofed, and low elevation signals. So as I mentioned before, a 25-degree elevation. Satellites that are above that should be where we're getting our signals coming from. So we want to make sure that is happening there. Anything below 25 degrees, we do not want to measure those signals because that could indicate that we're being spoofed from onshore or from another ship. The one thing that doesn't come into play though nowadays is drones. You could spoof a signal from a drone potentially, and that is higher than 25 degrees, especially if it's flying above and over your ship. So how do we handle that? So our other techniques show that we could handle that drone spoofing our ship, because drones are becoming more and more relevant within the Middle East, as we're seeing with different attacks within the Houthis, within Iraq, within different areas. Drones are being used not only as weapons, but they can be used for intelligence, surveillance, reconnaissance, and for spoofing and other nefarious effects within the shipping industry. So we also want to hold quality. Can we just go back one slide, please? Yeah, sorry. So we want to make sure that we have an independent timing source, such as a rubidium or cesium clock, that can freewheel with the sufficient accuracy for long enough that proper GPS reception can be restored after an incident. And one of the most common systems is inertial sensors. Inertial sensors help with making sure that we are on track. So because inertial sensors measure motion and movement, and again, time. So inertial can help as well to make sure that we're actually receiving the right location. And we want to add sensors and blockers. Sensors can detect characteristics of interference, jamming, spoofing signals, and can provide local indication of an attack or a condition. But another key step that we want to do on top of all of these is education. Education and understanding of our technology and what is going on with our technology, how it can be spoofed. Do we incorporate this into our testing? Do we incorporate this into our procedures and policies? How can we ensure that our PNT systems are working accurately, and how do we make sure our staff and crews understand this? And our port staff, how do they make sure that and be able to witness if a ship is behaving odd or if something's happening within their own systems on the port communication? So we've got to make sure that education comes into play. So if we go on to our next slide, is practicing good cyber hygiene. So it's the virus protection, it's the firewalls, software patches, updates, two-factor authentication. So we want to make sure that everything works well, because all our global navigation systems are connected to computers. We have our operational technology, we have our information technology on ships. But if they all go back to one computer, we've got one point of entry on that computer, which has potential to be hacked. If that computer is managed just by one person, it ties in the relationship between IT and OT, have we got a firewall between there? And the operational technology could be easily our antennas, our receivers there, our inertial systems. How are we protecting them? With firewalls, virus protection, the software. Because even behind these antennas and everything, there is software, there is hardware involved in it. Is the firmware being updated correctly? So we want to make sure that our systems are secure. And that there is the quick presentation. Went a little bit faster than I expected. So if you have any questions or ideas, like I said, I want to present some ideas of how to protect your systems from an actual implementation point of view. And we've covered the Iranian situation, but situations have happened off the Eastern Med as well, Black Sea. We've got situations where spoofing, where we've had ships that were within the Mediterranean, but they showed up offshore of the United States of America. And so we got these incidents happening. And it's showing more and more that technology is penetrating into the shipping and navigation side. And with the Suez Canal incident, as I said, someone thought it was a cyber event. Yes, a cyber event could happen. But when you look at the way the Suez Canal is set up, we go directly into dead reckoning. We follow flags, we follow signals. So in the situation there, we go into our environment of following rules and regulations. So in the case there, GPS is not an issue because we're following the instructions of our pilots, the instructions of the Suez Canal Authority. Several antennas and GPS allowing to detect low distance spoofing and jamming. Do these systems work? Yes, some do. They're still not 100% there though, because we're still getting a lot of vessels that are being spoofed. So GPS firewalls do work to a certain extent, but the key point is, I would say, if you have several antennas and you have the spoofing antennas, the fake antennas, if you can create that honey pit, that honey trap, then you can determine whether you're being attacked or not. So you want to fake it, and it's deception. And that goes back to our very first presentation, deception. We can use deception to convince our attacker that this is actually where we want you to hit. We put these on networks. So why can't we do that within our GPS systems? Deceive the person attacking us. And by having multiple antennas, and like I said, mentioning on the bow and port or starboard side, depends wherever you want to put it, you can determine the distance between these two signals, what's going on. And if the signal changes, then we know that one of the antennas is being spoofed. So it's better to have multiple ways of determining whether your systems are being spoofed or not. Till we get more encrypted systems, till we get receivers that operate with multiple GNSS systems. Right now, almost everybody works with your GPS systems because it's free as accessible. Galileo requires paying into it. BIDO requires paying into it. So there's different ways that happen. The GPS system is looking at being changed to have encrypted systems, and telling the equipment manufacturers, we have to have an encrypted code or key between it. So that way they're putting some security into it. So that way it can't be spoofed, but they're working with the manufacturers of the systems. Again, it will take time. We've had satellites up there since the early 80s, so quite some time when it came up. And the satellites have constantly changed and better improved. But in the GPS side, the signal is quite weak. And the US has a philosophy of keeping it open to the public because they see that as an advantage. When GPS first came out in the early 90s, and it was more secure system. There was two systems. There was the secure and the open system. The open system had a discrepancy of about 10 meters. The secure system used for military was down to centimeter level because they had encrypted, spoofed them themselves. It wasn't until the late 90s, early 2000s that they opened the system up to everybody else. So it has been done in the past because it was initially developed within the military system. But they could go back to that again. But then there was ways around it. We did differential GPS. Again, the point of having two receivers, we could measure the differential. We had a control station. It would measure the variance in the system and send out a corrected signal. So we worked around the spoofing. Now, why can't a cyber criminal do that? There's multiple ways. And I always say when I teach cybersecurity is think like a criminal. How can you actually go about doing this? And there's multiple ways. Think deceivious, think nefarious, and then you can protect your systems. And you can train your crew and staff on how to be aware of it. So that's my presentation.